Today we are going to learn about mastering SQL window functions for advanced analytics. We'll explore how to efficiently use window functions to derive valuable insights from data, enhancing your skills in advanced SQL analytics.
Welcome to this educational video on mastering SQL Window Functions, an essential tool for advanced analytics. SQL Window Functions allow you to perform complex calculations across a set of table rows related to the current row, without the need for intricate subqueries. These functions are pivotal in analytics as they provide the ability to perform operations like ranking, running totals, and moving averages, which are not possible with standard aggregate functions. In this video, we will delve into the intricacies of window functions, starting with their basic syntax and differences from aggregate functions, and gradually moving to real-world applications. By the end, you'll be equipped with the knowledge to extract deeper insights from your data. Let's begin by understanding what window functions are and why they're indispensable in analytics.
Now that we've introduced window functions, let's explore their syntax. At the heart of any SQL window function is the over clause, which defines the set of rows the function operates over. This clause can include two optional components: partition by, which segments the dataset into partitions, and order by, which determines the order of rows within each partition. For example, in the function call SumSalesover, partition by sales_region order by sales_date, partition by divides the data by sales regions, and order by arranges the rows by sales date within each region. This syntax is crucial as it allows for complex row-level calculations without the overhead of multiple subqueries. Throughout this video, we'll see various examples that highlight how these components interact to produce meaningful analytics. Understanding the differences between window functions and aggregate functions is crucial for leveraging SQL effectively in analytics. Aggregate functions, like sum, average, and count, summarize data into a single result per group, effectively collapsing the dataset. In contrast, window functions maintain the original row structure, applying calculations across a window of rows and returning a result for every row in that window. This non-collapsing nature allows you to retain the detailed context of each row while performing operations like ranking, cumulative sums, and moving averages. For example, using average sales over partition by sales_region gives the average sales for each region while retaining each row's data, unlike a simple average sales which would output one result per region. This distinction opens up new possibilities for in-depth data analysis, which we'll explore further with practical examples. The partition by clause is a powerful feature of SQL window functions, allowing you to segment your data into logical groups before performing calculations. By defining partitions, you can calculate results like totals or averages within each group independently. Consider a sales dataset where you need to calculate the running total of sales for each region. Using partition by sales_region in the window function ensures that the running total is calculated separately for each region. This capability is invaluable for maintaining the context of your data and ensuring that calculations are meaningful and relevant. In the upcoming examples, we'll apply partition by to various datasets, demonstrating its impact on data segmentation and analysis.
The order by clause within a window function is essential for defining the sequence of rows within each partition, which directly impacts the calculation results. For operations like ranking or calculating moving averages, the order of rows is crucial. For instance, when using row_number over partition by sales_region order by sales_date, order by sales_date ensures that the row numbers are assigned based on the chronological order of sales within each region. This sequencing is vital for accurate analyses, such as determining rank or calculating progressive sums. In the following sections, we'll see how order by can be applied in various scenarios to produce insightful analytics.
Window functions like row_number, rank, and dense_rank are commonly used for ranking data within partitions. While they may seem similar, each serves a distinct purpose. Row_number assigns a unique number to each row, even if there are ties. Rank assigns the same number to tied values but leaves gaps in the sequence. Dense_rank, on the other hand, assigns the same rank to ties without leaving gaps. For example, in a sales leaderboard, using rank might result in ranks like 1, 2, 2, 4, whereas dense_rank would produce 1, 2, 2, 3. These functions enable us to rank data effectively, a common requirement in analytics for identifying top performers or outliers. In the upcoming examples, we'll apply each function to real-world datasets, highlighting their differences and best-use scenarios. Window functions extend the capabilities of standard aggregate functions like sum and average by allowing continuous calculations across data rows. For example, using SumSalesover order by sales_date calculates a cumulative total over a period, providing insights into sales growth over time. Similarly, average sales over partition by sales_region order by sales_date rows between 6 preceding and current row computes a moving average over the last 7 days for each region. These types of calculations are crucial for identifying trends and patterns in data, offering a window into past performance and future projections. In this section, we'll explore practical examples using sales data, demonstrating how these functions can be applied to derive actionable business insights.
While window functions are powerful, they can also be resource intensive, impacting query performance, especially on large datasets. Optimizing these functions involves several strategies, such as using indexes to speed up order by and minimizing the number of partitions. Consider a query with a complex window function. Ensuring that your data is appropriately indexed can significantly reduce execution time. Additionally, avoid unnecessary calculations by limiting the number of rows processed within each window with rows between clauses. In this block, we will discuss practical optimization techniques and examples to help you balance query complexity and performance, ensuring efficient data processing and analysis. SQL window functions are invaluable in various business analytics applications, from sales tracking to financial analysis. For instance, in sales analytics, window functions can rank products based on sales performance, identify top performing regions, or calculate cumulative sales over time. In finance, these functions can be used to compute moving averages for stock prices, aiding in trend analysis and forecasting. Customer segmentation is another area where window functions shine, allowing for detailed analysis based on purchase behavior and demographics. Throughout this section, we'll highlight real-world case studies and examples, demonstrating how window functions can transform raw data into strategic insights, driving informed decision-making across business domains.
In this video, we've explored the powerful world of SQL window functions, essential tools for advanced data analytics. From understanding the basic syntax and differences from aggregate functions to practical applications with real-world data, we've covered a wide array of topics designed to equip you with the skills to derive valuable insights from data. As you continue your journey in mastering SQL, remember the importance of these functions in simplifying complex queries and unlocking new analytical possibilities. We encourage you to apply these concepts in your projects, experimenting with different datasets and scenarios. Thank you for joining us, and we look forward to seeing the innovative ways you'll use SQL window functions in your analytics work.